Good afternoon and welcome back. We are in lesson 19. We're going through problem number 3. You should have your math module book, a pencil, and an eraser. We are going to answer all of the questions here in number 3, but we're first going to review over here on the right this family tree of four-sided shapes that we've been looking at now for 2 weeks. I call this a hierarchy because the quadrilateral here at the top has the fewest requirements for shapes that you can call quadrilaterals that will fit into that category. So any shape is a quadrilateral if it has four sides. So if it has four sides, it's a quadrilateral. It goes into that category. But watch as we start to specialize. There's obviously different kinds of four-sided shapes. The first shape we looked at that was four-sided was a trapezoid. And this doesn't have many requirements either. The only requirement a trapezoid has is that the shape must have two pairs of parallel lines. Okay, so you must have two parallel lines. One here, I think I just said pairs. You don't need pairs. You need two parallel lines. So two of the lines have to be parallel to each other. And we've shown the motion for that, right? Parallel lines are ones that are always equal distance apart and never intersect. Okay, so a trapezoid has two pairs of parallel lines. Then we looked at kites. Kites are interesting because they're also quadrilaterals with four sides. However, they're a little bit more specific. These shapes have adjacent side measures. This measure and this measure, these two lines, are going to be the same length. And then these two lines, these lines that are next to each other, will also be the same length, but they won't be the same as each other. So this top half will have two lines that have the same side lengths, and these two bottom lines will have side lengths that are the same, but they won't be the same as each other. Okay, so this will be the same length as this, and this will be the same length as this. That's a special kind of quadrilateral. And then lastly, we looked at parallelograms. These are four-sided shapes. They're quadrilaterals, but they have to have two pairs of parallel lines, okay, that are opposite from one another. So here's a parallel line, and here's a parallel line, and then here's a parallel line, and here's a parallel line. But you can even specialize with a parallelogram. You could be looking at a rhombus. A rhombus has two pairs of parallel lines, here and here, and here and here. But a rhombus has side measures that are all the same. Every single one of these lines has the same length. Okay, and then a rectangle is also a parallelogram. It has four right angles. That's what makes it a special kind of parallelogram. Okay, but it's still a parallelogram. Look, it satisfies the requirement. It has parallel lines, two pairs of them. Same thing with the square. This has two sets of parallel lines, but a square, like a rectangle, has four right angles, and like a rhombus, all of its side measures are the same. Okay, that's a lot. I know it's a little confusing. Let's list the properties shared by all the squares we worked with today. Well, they all have four right angles. They all have the same side length. And they all have four sides. Okay. List the properties shared by all the kites. All have four sides, but two pairs of adjacent side lengths. And then when can a rhombus be called a square? When it has four right angles and the same side lengths. Okay? And a kite can be called a square for the same reasons. When it has four right angles and all the same side lengths, that's a square.